Hey everyone, I'm Alex here at Haas, and today I'm going to show you how to set up this new HC10 Cobot to load this material into this VF2 and run some parts. Our Cobot has already been connected to the machine, and we have our light curtains, parts table, and Cobot fully secured to the optional wooden base where we want them. Your HFO should have gotten you this far, but you can also check out our instructions linked in the description for more information. Now, before adding any kind of automation to a CNC, we need to be sure that our cutting process is stable and capable of running multiple parts unattended. This is a very simple part with wide open tolerances, and we've run this program thousands of times here at the factory. Because of this, it's a great choice for automation. You never want to automate a brand new program or complex, tight tolerance parts until you become experienced at running lights out. To begin, I'll adjust my vise jaws on this Haas air vise so that when the jaws are open, the material rests on these flats without being able to fall in between the jaws. I also want to make sure it's held securely when the vise is clamped. You want the jaws to open as much as possible to make loading your parts easier. I'll go ahead and I'll finish my mill setup just like I would on any other job. Now that our part is completely set up on the mill, we'll begin to program the Cobot. We'll start by configuring the collision sensitivity or security setting of the Cobot. To select the security setting, we'll need to log into the teach pendant of the Cobot. I'll enter the username and password, admin, all lowercase. Navigate to the config tab and open the security window. I'll enter the password, admin, again at the bottom of the page and press verify. I can now choose my desired security level and press apply. This setting controls how much force it takes to stop the Cobot. Level 0 is the most sensitive and the safest setting, but requires slower operating speeds and more accurate payload settings. Level 5 is the least sensitive mode, and the Cobot will behave closer to an industrial robot, allowing for higher speeds, but with more risk of damaging equipment and operators. Your security level setting will be based upon your risk assessment of your Cobot cell and application. It's your responsibility to ensure that the proper safety standards are met to protect yourselves and your operators from injury. You should have completed a safety acknowledgement form before purchasing your Cobot, and that form can be found on our website here. Today, we're using a cell with a completely enclosed light curtain, so I'm going to use a security setting of level 3. This allows me to operate the Cobot a little bit faster, and I don't have to be ultra precise with my payload settings. Each security level has a recommended max operating speed shown in this column here. For level 3, that value is 1500 millimeters or 60 inches a second. Remember that value. We're going to need it again in a bit. Once the security setting is set, we're done with the Cobot teach pendant. The rest of the setup and programming will happen right here at the Haas control. To start, I'll navigate to Current Commands, Devices, Robot, and Setup. Verify that the control is connected to the Cobot. If it's not, press E-stop and press F1 to connect. Once it's connected, release E-stop and clear the alarms. Now, I'll fill out this table. The max robot speed we will set to 60 inches a second. This is the value we got from the security level setting inside of the teach pendant. The gripper net mass is the weight of the entire gripper assembly without a part. I'm going to enter 7.5 pounds for these dual grippers. These weights can be found on the grippers page of haastooling.com for all of the gripper options we sell. Because I'm using a higher security setting and collision detection level, I don't need to be super accurate. For lower, more sensitive security settings, it may be necessary to use the Cobot's self-calibrating payload function. I'm using an end effector with 2 grippers, so I'll enter 2 for the number of grippers. The raw gripper clamp and unclamp outputs correspond to what solenoids are triggered to clamp and unclamp the pneumatic grippers. The factory settings are raw gripper clamp 1, raw gripper unclamp 2, finish gripper clamp 3, and finish gripper unclamp 4. These control which coil of the pneumatic solenoids are triggered for each clamp or unclamp action. The clamp delay tells the control how long to pause the robot motion when a clamp or unclamp command is sent. We don't want the robot to be moving while trying to grab a part, So I'll start off with a value of 1 second. A value of 0 would result in the robot not stopping at the pickup and drop-off locations, and it would try to grab the part in an inconsistent location, potentially misloading it into the vise. The clamp type lets the controller know if we're picking our parts up on the inside or the outside. Today, we're picking up the material and the finished part on the outside with both grippers, so I'll leave that setting on outside. But if I wanted to grab something from inside, like a bore or a pocket, I could configure either of the grippers to do that here. Navigate from Setup to the Jogging page. We'll fill out this table just like we did on the Setup page. We haven't made any frames yet, so we'll leave the coordinate type, tool frame, and user frame at their default settings. We'll talk about frames in a minute. The max jogging speed can be set anywhere from 1 to 7.9 inches per second. I'll put this at the max of 7.9. I'll also enter a mass of 0.2 for my finished part and raw stock mass. Again, my security level settings let me be a little fast and loose with these values. It may be necessary to accurately weigh your raw stock and your finished part with more sensitive settings. Next, I'm going to use F2 and F3 to actuate my grippers and make sure that they are working properly. I'll also adjust these fingers to be able to hold on to my raw stock and my finished parts. Now that the jogging page is complete, let's go over how to jog the robot. There are 2 ways to do this, using the Haas remote jog handle or using the Cobot teach pendant. Let's go over the jog handle first. Put the control in setup mode. This will automatically lower the max robot speed and allow us to jog with the door open. You can jog the Cobot around either by moving joints or by moving the grippers along an axis. Hold F2 on the jog pendant and use either the arrow keys or the jog wheel to move the Cobot around. The jog increments at the top of the screen will control the robot's speed. Now, let's jog the robot with the teach pendant. Navigate to the jog tab. Use the axis buttons to move the Cobot along a direction and rotate, or the buttons on the end of the joint sliders to move a joint. The speed slider will control the speed, and the step function can be toggled to have each button press move the robot the distance specified in the box. I get a lot of questions about this button labeled free right here near the grippers. It's worth noting that this button also enables Freedriver mode, but only if you enable it inside of the teach pendant. Navigate to the monitor tab, go to End I/O and enable End I/O. Now, pressing and holding the Freedriver button on the end of the arm will automatically enter Freedriver mode, and releasing the button will exit. So another way you can enter Freedriver mode is to go into the teach pendant under the jog tab and press the Freedriver button at the bottom of the menu. Now the Cobot is permanently in Freedriver mode until you push the button again, so you can move it around without holding down the button. Freedriver mode will cause an alarm to occur on the Haas control. Once the Cobot is out of Freedriver mode, simply clear the alarm to continue. The bottom line here is that regardless of which method you choose, we want to position the robot in a place where our grippers are easily accessible. So, gripper 1 will be used for my raw material, and gripper 2 will be used on my finished part. Clamp and unclamp the grippers and bring your material up and make sure that the stroke of the grippers is going to fit over the material and hold on to your part where you want it to. I like to use this 3/8 tubing over the fingers to act like soft jaws so that the steel fingers don't damage my finished aluminum surface. Just like our vise jaws, you want to set up each gripper to open as wide as possible while still being able to securely clamp onto your part. Okay, let's talk about frames. Take a look at this picture. In this photo, there are 4 frames that we need to set up. 2 tool frames, one for gripper 1 and another for gripper 2, and 2 user frames, one for the parts table and one for the machine. But as far as the robot is concerned, all of these frames are currently set to their default values. our job to update these default positions. We need to move them to new locations that'll work better for our setup. Let's start with the tool frames. Tool frames define where the tool center point of our grippers are. They are the robot equivalent of a tool offset. On the HC10, the default tool frame origin is located at the center of the wrist joint, with positive Z coming out of the joint and minus Y aligned with this electrical port. The right-hand rule can be used to determine the location of the positive X axis or any other axis you need. If I rotate the Cobot by jogging either the W, P, or R axis, you can see that it rotates around this origin. This isn't going to be useful when setting up the Cobot. I want it to rotate about the approximate point where I'm going to be holding onto my part. I'll measure out the distance to where I want my new tool center point to be along each axis. That's going to be minus 5.5 inches in X, 0 in Y, and 5.5 inches in Z for tool frame number 1. Gripper 2 is going to be the same thing, but we're going to use plus 5.5 inches on this side, 0 for Y and 5.5 inches for Z. I'll input those values into the control by pushing enter to bring up the direct entry menu. Now, if I select the Gripper 1 tool frame and jog the W, P, or R axis, you can see that the rotation occurs around our gripper fingers. Okay, on to user frames. User frames are equivalent to your work offset. Remember that we need to make 2 user frames, one for the parts table and another one for the machine. Let's start with user frame 1 here on the parts table. The default user frame origin is the center of the base with the Z axis coming out of the joint and the positive X direction aligned towards the electrical connector. If I jog along X, we can see that the default world frame is close, but it's not perfectly aligned with our parts template. We need to correct that. You can use the direct entry method to create user frames like how we just did on our tool frames, but the 3-point method is a little more accurate. Press insert to bring up the 3-point method pop-up. For my parts table user frame, I'll set the origin to be here, down in the lower left. This is important because the grid table parts template will pick up parts only in the positive and X and Y directions from where I choose my first point. I'll jog the robot and align this gripper finger as closely as I can with the corner of this grid square. I'll be sure to touch the gripper finger to the table each time to make sure that the plane I'm creating is parallel to my parts table. If these points are recorded at different heights from each other, the frame will be recorded at an angle, and we don't want that. I'll jog the robot to the farthest location of my grid template along what I would like the direction of the positive X axis to be. Again, I'll align the gripper finger with the template square. I'll do the same thing to set my positive Y direction. Once the frame is created, I'll make it my active frame by selecting it and pressing F2. Now, I'll jog the robot in the X, Y, and Z directions to verify my work. I'll repeat the process to create a second world frame based on my mill table. I like to align this frame to the machine axis so that it's harder for me to get confused. Positive X to the right, positive Y to the back of the machine, and positive Z up away from the table. That's it for the frames. We're ready to start programming. I'll move from the Robot tab over to the Automatic Parts Loader tab, where I'll need to fill out the tables in the Template, Load Part, and Unload Part windows. We'll start over here in the Run Job tab. Here, I'll press F4 to bring up my file options and create a new job. I'll name it and leave it in the default directory. Now, I'll navigate to the Template tab and begin filling out the table. The first operation is to define the sequence type. We can pick between simple or custom sequences. I'll use a simple sequence that's pre-built in the control to load these parts. The next things to fill out are the raw stock pickup and finished part drop-off methods. We can choose between either a single point or a table grid. The table grid picks up parts from an array and indexes the pickup and drop-off locations automatically after each part. The single point setting is used if you're picking your parts up from something like a parts hopper or a conveyor, where the next part is always going to be in the same spot. The dual table option under the drop-off menu lets you pick up parts on one table, run them, and drop them off on a different table. I'm using one grid table, so I'll select table grid and single table. I'm not going to be stacking my parts in layers on my table today, so I'll leave the stack parts field at 1. The number of rows defines the number of parts along the y-axis. This template has spaces for 6 rows, but I'm only going to run a few parts for demonstration purposes, so I'll only put 2. Similarly, the number of columns is the number of spaces along the x-axis. I'll put 4. I'll enter the values for the distance between my rows and my columns. Any errors in these values will compound each time the robot indexes, so it's important that these are accurate. You may get better results by measuring the entire grid and using the average spacing as opposed to measuring one individual spacing. Today, I'm going to use my calipers to measure the spacing of one grid square as accurately as I can. We're only running one side of these parts today, so I'll leave the part flip sequence disabled. I'll enter the raw stock and finished part mass again here. The parts template is now completely defined, so I'll move over to the Load Part tab. Here, we have another table to fill out. I'll select my air vise in the raw stock work holding tab and use F4 to verify it functions. The robot speed value here affects how fast the robot is going to move when it's picking up parts from the table. I don't want to go full rapid here because the chances of a collision are higher, so I'll set it to 10 inches a second. The initial pickup location is where the robot is going to pick up the first piece of material. Before jogging the robot into position, there are a few things we need to check. We have to make sure that our correct frames are active. Gripper 1 tool frame and the parts table user frame. And we need to position the robot in a neutral state between the table and the machine and make sure we're starting somewhere in the middle of the joint travel. I like to have the teach pendant open and on the jogging tab while doing this. The sliders on the left show all the joint positions relative to their max travel. These joint positions all look pretty good. Now, I'll position the Cobot roughly above the first part using Freedriver mode. I'll use the jog wheel to align the gripper with the material and jog down to the height I'd like to grab it from. I like to slightly offset my grippers so that when the fingers clamp, they pull the part away from the template edge, and that helps prevent the part from getting hung up on any lip that might be there. Use F3 to open and close the gripper. Take your time and get this point as dialed in as possible. It will be easier to load your vise if everything starts nice and square. Once I'm happy with my gripper location, I'll reposition the part in my template exactly like how it's going to be when it gets picked up. Use F3 to close the grippers and save this point. The next point we need to enter is our above table location. This is exactly what it sounds like. This point controls the height that the gripper will be at as it travels above the parts table. So I'll jog straight up in Z to a height where my gripper holding a part will clear all of the other parts on the table, and I'll give it a little bit extra. The grippers will need enough clearance to be able to rotate from gripper 1 to gripper 2 at this height. This position looks good, so I'll go ahead and record it. The next thing to program is the ready motion. This is the first motion file we'll need to create, and it defines the path from the above table location to a position somewhere in front of the machine where the robot can wait for the cutting program to be finished. The GIFs and images in our control all show what each motion file needs to accomplish. The first thing we'll need to do for every motion file is press F1 to launch the setup options. Here, we can select from joint or Cartesian coordinates, set our initial speed and our frames. Joint mode stores the positions of the joints for each point and lets the robot optimize its path from point to point. You should always use joint mode unless absolutely necessary. I'll stick with the gripper 1 tool frame and the parts table user frame. I'll set the speed to 30 inches a second. There isn't much chance of the robot hitting anything, so I can move faster, but there's no need to max this out. This motion file will happen while the machine is cutting, so moving fast here won't save you any cycle time, and it will add unnecessary wear and tear to your Cobot. Setting the speed closes the setup window and automatically populates the speed in the first line of the motion file. A speed needs to be chosen before any points can be recorded. I like to start my ready motion with the exact same point as my above table location. So before I move the Cobot, I'll save that point by pressing Enter on the Add Action line to bring up the list of actions and choosing Record Robot Position. Next, I'll move the Cobot to an intermediate point and record another point. This point helps ensure that the robot won't crash into itself or break the light curtain. You may need more or less points to navigate around your Cobot cell. Typically, troubleshooting and modifying programs becomes more manageable and the overall motion appears smoother when using a smaller number of points. I'll position the Cobot in front of the doors with enough clearance for them to open and close and record the final point. Next, I'll press F2 to bring up the run options. I'll run the motion file in reverse to return back to my above table location, and then run it going forwards to verify that there are no problems going back and forth from the parts table to the machine. The rapid override keys can be used to control the speed, but they won't affect the robot while it's in motion. They need to be set ahead of time. Pushing reset or e-stop will stop robot motion at any time if it looks like it's going to crash. Great, that's all we need for our ready motion. Next, we need to position the machine table where we'd like to load our part. I'll swap to an empty tool, move Z all the way up, bring the table all the way forward, and approximately align it in X with my Cobot. I'll record this position using F2. Now, we need to create our raw stock load motion. I'll open the recorder window and launch the setup options again. I'll stick with joint coordinates, switch to my mill table user frame, and up the speed to 60. I'll record the first position to be the same positions as the end of my ready motion. I'll add one more point in line with the plane of the doors to ensure we clear them, and another point roughly above the vise. Now, I'll press F1 to launch the setup options again and switch to Cartesian mode. I'll carefully jog the material into my vise, taking my time and making sure it's aligned absolutely perfectly. I like to set my height position so there's just a little bit of force from the Cobot pushing my material down into the vise jaws. Without unclamping the gripper, actuate the vise to verify the position of the material. If the gripper is off center, closing the vise will visibly pull the robot out of position. When it's perfect, there should be no visible motion of the robot from opening and closing the vise. I like this position, so I'll record this point. Now, I'll insert 2 lines above this one in my motion file. I'll jog Z straight up from the vise and record another position on one of these lines. Make sure it's in Cartesian mode because we want to come straight down into the jaws. On the other line, I'll set the speed to 5 inches a second so that we approach the vise nice and slow. I'll use the run options to run back and forth between these 2 points and make sure that the vise is being loaded consistently. Then, from the load position, I'll run the entire sequence in reverse and then back again forward to verify that the load motion is good. The robot should load the vise for me and unclamp. I can either run the motion in reverse again or use Freedriver to get the Cobot out of the machine. Because we're using simple mode, the control will automatically take care of opening and closing the doors, the vise, and the grippers. All we need to worry about is recording robot positions. Now, I'll redo my G54 work offset to match the location of where my Cobot is loading my material into the vise, since this is probably going to be a little different than where I initially set up. Now, you can either run your cutting program or swap out this raw material with a completed part. Use calipers or a reference to make sure that your finished part is in the exact same place as where your robot is loading the raw material. Now, we'll tab over to the unload part page. The unload part page is similar to the load part page. I'll select my air vise for the finished part work holding. This might be different if you're running a lathe and loading the main spindle, but unloading from the sub-spindle side. But here, I'm only using the one vise. We'll create the finished part pickup motion the same way we did the load part motion file, but we'll use the Gripper 2 tool frame and the mill table user frame. Starting from the end of ready motion, I'll use high-speed joint moves to get close to my finished part and switch to slower Cartesian points to do the final approach. We'll use Gripper 2 to unload our finished part. I'll leave the part clamped in the vise and open and close the grippers on it to check my final position. There should be no visible motion when clamping and unclamping on the part. Any motion means that the grippers are off center and our robot is out of position. Once I'm satisfied with the point and it's recorded in the controller, I'll run the motion file in forward and reverse to verify that everything runs smoothly and that there are no collisions. Now I'll record the gripper swap motion. This is where we're going to clamp onto this finished part, unclamp the vise, raise it above, and swap from gripper 2 to gripper 1. Gripper 1 will already be holding a new piece of material and will be ready to load the vise when the program is already running. So, we've already made some motion files step by step. For the rest of this video, we're going to swap to a split screen and I'm going to record the rest of the robot motions live and in real time. Enter to bring up the gripper swap motion. We're going to use the gripper tool frame and the mill table user frame. We're going to set the speed to 1 inch a second again. This first point is going to be the same point as the end of our unload part motion. So I'll clamp the gripper and unclamp the vise. Go back into my gripper swap motion. Add a point straight up in Z. Record this position. Switch to joint mode. And I'll rotate the gripper using joint 6 so that gripper 1 is now pointed directly at the vise. Remember, when this program is actually running, gripper 1 is already going to be holding material, so you need to factor in extra clearance for that. So like all my motion files, I'm going to run it in forward and reverse to make sure everything is operating as intended. Moving down the table, the next option is an optional chip clearing sequence. You can use this to set up an air blast to clean your vise jaws of any chips or swarf. We're not going to use that today, but you should always have something like a chip fan, a coolant wash, or this option enabled when running an automated part. When the robot is running, gripper 1 will almost always have a piece of raw material in it ready to go. At this point in the setup process, we need to tell the robot how to put that raw material back into the vise. That's essentially what this step, load after swap, is asking. The good news is we've already recorded most of these points in our raw stock load motion file. All we have to do is use those points again. Let's do it. I need to hop back into my gripper 1 tool frame and I'll run the robot to my vise loading locations and save these points. All right, so we bring up the load after swap motion. We bring it up by pressing enter. So we'll start, push F1. We want to be in joint coordinates, so we are not going to set it to linear coordinates. Set speed, press enter, 60 inches, enter. It auto-populates that first line. We'll make sure we're in the frames we want. So I'll set my tool frame, gripper 1, push F1 again, set our user frame to the mill table. And we will record the position of where the robot is right now. This is the same spot that the gripper swap motion ends at. Now we record this robot position in joint mode without moving it whatsoever. We're going to close this motion file. Go to our load part. Bring up the raw stock load motion file. Bring it up. So this first joint move is going to be the rough position way above the vise. So F2, not run all, run selected. We already have that point saved. So we'll go down to the next point, F2 again, run to that point. All right, so we're there. We exit this file. We go home. Up into the unload part tab, reopen load after swap. At this point, we are going to push F1. We do want to set to linear coordinates, switch to Cartesian mode as I've been saying in the video. So we'll click that. We'll record this position. We're going to insert a line above it and we're going to set the speed to 1 inch a second so it matches the other file. Close this one. Go back to the load part tab. Go to the raw stock load motion file. Go to our final vise load point, so select it. F2, run selected. Lowers gently into the vise, nice and slow. Close this file. Go back into the load after swap file. And record this point. It is done. Run backwards and forwards like every other motion file. F2, run all in reverse. Boom. F2, run all. Beautiful. And that wraps up the load after swap motion. Okay, the final motion file we need to create is the unload part file. Remember, the file we just created will have loaded a fresh piece of material into the vise right here. Now, we need to get the robot out of the machine holding our finished part and get ready to unload it. So we bring up the recorder for unload part motion. Like all of them, we're gonna start by pushing F1. We don't want to be in joint coordinate just yet, so we'll leave that. We'll set our speed to 1 inch per second for right now to clear our part. F1 again, check our tool frame. We're still using gripper 1. F1 again, check our user frame. We're going to be wanting to use the mill table. At this point, I'll record the robot position exactly where it is. Next, I will take the jog wheel, jog up in Z, somewhere high enough to where I know I'm going to clear my part. Record that position. Switch to joint mode by pressing F1. I'm going to speed it up back to 60. And then I'm just going to use Freedriver mode to get it out of the machine and record a point. And that's pretty much it for unload part. The final point to record is the finished part drop-off location. To do this, we need to jog our finished part in gripper 2 over to the table where we'd like to drop it off. All right, so to get to the drop-off location, I'll Freedriver the robot roughly over where we want to drop it off. Switch back to the jog pendant. Take the air gun with us. So we're just gonna keep slowly bringing it in. We'll rotate it a little bit. And that's probably good right there. So I'll go to the drop off location tab, press F2, and that will record it. All right, and that's it. We're done programming the robot. Congratulations. All right, we can finally prove out our robot program. I'll move over to the Run Job page. The job name should be highlighted in red text. This means we have unsaved changes. I'll press Insert to toggle APL mode on and on again to save my progress. This can be done at any point during your programming. Here, I can edit the total number of parts I'm making, tell it what part to start on, link an O-numbered cutting program, or perform an additional post-run or pre-run sequence. I'm going to start proving out my entire robot program without cutting, so I'll leave the program line blank for now. I'll switch over to MDI and use a simple 2-line program to prove out my motion file. M0 followed by an M299. The M0 will stop the program and allow for me to swap out the raw material in the vise with a finished part, and the M299 replaces an M30 for all robot and automatic part load programs. I'll swap back to the current command tabs and press undo to move the robot to a safe position. This is the same position as the above table position we recorded at the beginning. From here, it's going to pick up our first part at the initial pickup location. It's going to move to the above table, and now it's running the ready motion. From here, the door should automatically open, This is the start of the raw stock load motion file that we created. I'm watching just to make sure everything's going the way I want it to. It's loading the part in the vise. Now it'll automatically come outside of the machine, the doors will close, and here's when your cut program would start running. However, since we're testing, we just have an M0 as a placeholder. So while the machine is running, the robot would be doing this, going to our next piece of material, picking it up, and it's gonna go back through the ready motion and wait in front of the machine doors. At this point, during normal operation, the robot would wait for the CNC program to finish and go ahead and unload the next part. However, since we're proving stuff out, I'm gonna go ahead and swap in my finished part and use my calipers to make sure it's exactly where it will be in the final machine state. Once my part is swapped, I can push cycle start to resume the program. We're now going to perform our unload part motion, gripper swap, and load after swap motion files. Again, because we use simple mode, our control is taking care of opening and closing the vise, the grippers, and the doors for us. We didn't have to worry about programming that at all. So there's our gripper swap. Here's our load after swap. Looks good. Remember, we programmed that without a piece of material, but the point should be the same as the raw stock load file. Here it's coming back out to the ready motion, doing the unload part motion file. And now it's gonna go run the ready motion in reverse, stop at the above table position, rotate to gripper 2, and deposit our part. That all looked good. So one cycle's complete, we're ready to actually run the job. We just finished proving out our robot program. We're ready to actually run parts now. To do this, I need to reset the robot program. The easiest way to do this is from the recover page. To get there, press the recover button and select the robot option. From here, I have access to control all of my grippers, my vices, and I can use the origin key to move the robot back to the above table origin position. I'll go ahead and do that now. In the current commands tab, I'll use origin to reset my current parts counter and my completed parts counter. I'll also select my CNC cutting program under the program line to link it to this robot job. Now, whenever I pull up my robot job again, my cutting program will automatically be tied to it, and I won't have any chances of running the wrong program. Once we're ready to finally run our program, I'll take the controller out of setup mode, arrange my parts on my parts template, and push cycle start to begin the program. That's it. Thanks for watching, everybody. We have a ton of information linked in the description and even more at our website at haastooling.com. So get out there and enjoy putting your newest employee to work, the Haas HC10 Cobot.